Testing the difference between proportions. Most of the time, we need to make comparison and analyze differences between two population proportions. The z-test with some modifications can be used to test the equality of two proportions. Let's take a look to our example here. Now, in this case, we want to compare the proportion for Canada and the United States in terms of if they answer the phone when they drive. Let's put our hypothesis first. The hypothesis would be H0 equals H0 P for Canada equals P for United States, and H1 would be P for Canada is not equal for P United States. The pi here stands for the Canadian proportion and the US proportion. So we want to find out if there is a difference between Canadian and the American drivers in terms of answering the phone when they drive. In order to see this, two surveys, one from Canada and one from the United States, has been done, and 1,000 survey from Canada and 1,200 from USA. Now, first of all, the second step of our hypothesis testing is to set up our critical values. Now, in order to find the critical values, we're going to use a z-test. Norm S-I-N-V, norm.s.inv, B5 divided by 2. The reason we divide B5 by 2 because B5 is 5%. As you can see from this graphic, 5% should be split, one to the left side, one to the right side, so it becomes 0.025. So let's see again our formula for the lower critical value would be norm.s.inv probability B5 divided by 2. So the critical value for the lower end is minus 1.96, and then obviously would be the same number because it's symmetric, 1.96 with a positive number. But still, I like to show you how do I find 1.96. Now this time you see we are not using B5 divided by 2 but 1 minus B5 divided by 2. The reason because Excel use the left side always. So instead of entering 0.025, I need to enter this area, which is 1 minus B5 divided by 2. So once we have the critical values, minus 1.96 and plus 1.96, then the next step is to find the test value. In order to find the test value, now we have a different formula for proportion. Now let me bring the formula here. So this is the formula for finding the z-test value. Now here P1 stands for the sample proportion 1, P2 for sample proportion 2, and pi 1 and pi 2, those are the population proportions. But since there is no difference, hypothesis difference is 0, we are not going to use this part of the equation. And there is also p bar. So far we never use p bar, so let me bring the formula for p bar. P bar equals x1 plus x2 divided by n1 plus n2. Now let's put our data on our spreadsheet here. So hypothesis difference is 0, level of significance 0.05, For the first sample size is 1000, and out of 1510 they say they answer the phone when they drive. For the United States group 2, there are 1200 surveys, and then 675 they say they answer the phone when they drive. Now the first group proportion, which is Canada, would be equal number of people answer the phone, 510 divided by 1000, which means B7 divided by B8. So 51% of Canadian sample they answer the phone. And similarly, out of 1200, 675 answer in the United States, which is 56.25. Now the test here is the 51% with 56.25%. Is this significant difference for the population? Now there is a difference in the sample, but if this is significant difference for the population. Now the difference in the two proportion would be B14 minus B15, and the average proportion in terms of p-bar, so this is basically p-bar, equals x1 plus x2. x1 is B7, x2 is B10, so B7 plus B10, x1 plus x2, divided by n1 plus n2, sample size 1, which is B8, plus sample size 2, which is B11. So p-bar equals 0.5386, which is average proportion. Now the reason I need p-bar, because I'm going to use the p-bar in this formula for z-test statistics. Now let's get z-test statistics. So basically this is B16 difference proportion right here, minus B4, which is 0, divided by SQRT, square root of p-bar that was B17 times 1 minus B17 times 1 divided by B8, which is first sample size, and plus 1 divided by N2, the second sample size. So let's take a look one more time. B16 is the difference, P1 minus P2. B4 is pi 1 minus pi 2, which is 0, divided by SQRT, P17, P-bar, P17 here is P-bar, minus 1 minus P-bar, so 1 minus B17, times parentheses, don't forget parentheses, 1 minus first sample size, 1 divided by first sample size, plus 1 divided the second sample size, 1 divided B8, 1 divided B8, and 1 divided B11. So the test value is minus 2.4596. So if you look here, minus 2.4596 is less than minus 1.96, which tells me H0 should be rejected, H1 accepted. There is a significant difference between American and Canadian drivers. I can tell this with 95% confidence. So the difference between 56% and 51% is significant difference.